principle. All right, so let's move on to number 8, which is where you get involved. Not do you don't, as a human in this process, you don't only bring your ability to manipulate the data set, but you also bring your own insight. We think it's an important principle to apply what you know to a situation. For example, as you apply feature crosses, you can think about how you can introduce your own insight to the situation. In this case, you understand the geography and know where lat-long distributions would be appropriate on a given map. Be deeply aware that the world is impermanent. So what we mean by that is that it's important for you to build for change. And the Google Cloud products have been designed to do so. We've talked a little bit about data prep and how it can be used. Data prep runs on Google Cloud data flow. And here you're seeing how data flow can be used to ingest a stream pipeline or ingest data from cloud storage, a stream through PubSub, or batch data through cloud storage. These can be written to either BigQuery or Bigtable. And using Google Cloud Machine Learning, or an environment like Data Lab with Google Cloud Machine Learning, you can apply some of the principles we discussed previously. What's great is that now you can do this continuously, whether across batch or streaming, which allows you to build for change. We're moving on to our 10th principle. That is how you handle faults. We don't need to be afraid of having faults. They can help us improve. But it's important that we shuffle our faults across the data set. Principle 11 is about using serverless infrastructure. So earlier I described how the Google Cloud products can help you have a batch and streaming pipeline, meaning you can do things in development mode and then stream them quickly in production. This topic is more about the fact that you don't have to manage that infrastructure, whether it's in batch or streaming. The serverless products in Google Cloud allow you to focus on the machine learning and analysis aspects and leave infrastructure to someone else. We're on to our final guide, which is final principle, that sometimes not getting what you want is wonderful. It's easy to spend a lot of time on a task and to arrive at failures. But if we fail slowly, we get through fewer tasks and our chances of success go down. This is just an encouraging principle that as part of your data preparation efforts, it's better to fail fast and to iterate. The more passes you have of something, the more likely you are to have success. This concludes our 12 principles of data preparation for ML and analytics. More easy to understand here are the typical terms we would use for them. As mentioned at the beginning, this is mostly about how we handle outliers. We need to understand and collect them, take those in the long tail and bucketize them, and make sure that we verified any assumptions and clean data. We have Googlers standing by to take your questions. So if you do have questions, please let us know. Thank you.
Great. Welcome back. What a fantastic session by Eric talking about the Zen guide to data preparation. And of course, data preparation means data prep. And data prep is such a fantastic tool, especially when you're talking about things like AI. Imagine essentially being able to run ETL workflows without actually ever having to worry about the underlying architecture and infrastructure. You're just creating these recipes to design your features and do that feature engineering that you can later feed into these AI models. And as we said before, a good AI model requires good data. But as Eric says, do you trust your data? You shouldn't. So use tools like data prep to sort of take a look at your data, develop histograms of your data, massage that data by looking at that data through different lenses, all based on these recipes. And then once you have that recipe right, then you can actually start to execute on that in batches and prepare your data before you even think about something like machine learning.
And of course, I think I agree. The best practices that were shared were really useful, and in terms of understanding how we need to kind of prep the data before kind of working further with it, because that's essentially going to be your base for any kind of queries that you run, right, eventually. So you need to have a proper form of data in that regard. And I think the next session that we're going to have in the big data track is going to be putting data security and privacy to practice with Google Cloud. So Jay, don't you agree that privacy and data security has been like a great part of what Google focuses on?
Yeah, absolutely. I mean, as you know, we've got 7 products with over 1 billion users, and in fact, Google Cloud Platform itself serves 1 billion users for our customers, and that data does have to be protected. And there are a number of ways that we can do that, which is covered in this next session. But going back to what we were saying around the sort of the healthcare industries and finance industries, which are heavily regulated, those organizations that can take advantage of the cloud are going to be able to move faster. And if you can figure out how to protect that data, and once you feel comfortable in protecting that data, you'll be able to take advantage of what the cloud has to offer. And again, as we said earlier, the customer engineers, we're here to help. So we're here to help you take a look at any sort of compliance, internal compliance that you have, or any governmental regulations that you have, or industry regulations that you have, to see how we can actually comply with that and let you take advantage of the scale and innovation that the cloud offers.
And also, just a preface to that is, we have a security website as well, which contains all of this information in terms of, the security measures that Google takes, the compliances, and all of that, the certifications that we have. So I would encourage all of you to kind of go through that. That's a really interesting piece out there, publicly available for all our customers to kind of ensure you that we are doing all, that's required in terms of data security and privacy.
Okay, fantastic. And as we were saying before, if you've missed any sort of session, obviously there are a lot of sessions here. It's hard to sort of decide sometimes. These actually will be shown again for EMEA, and you're welcome to stick around and watch those sessions as well.
Great. And all of these sessions are also being recorded, and they will be available later onwards in form of video on demand. So quickly again, joining in, we have our folks from Industry Solutions track. So they've just wrapped up about the new age of manufacturing and how data is kind of being used, and how big data, machine learning, and Google Cloud is enabling the manufacturing industry to be innovative and kind of be one step ahead than they used to be in the earlier days. So Jay, what did you think of that track?
Yeah, absolutely. I mean, obviously Jen did a great job talking about sort of how that's affecting manufacturing and the different ways that manufacturing is adopting a lot of these technologies, both on the manufacturing floor and afterwards. In fact, actually, I sort of also think about the previous session that they had around IoT, for example, right? So being able to track a lot of those things on the manufacturing floor, but also even beyond that. So how do you actually track things that have been manufactured, and how do you actually get that data back into your premises? How do you analyze that? How do you do things like preventative activities in order to see how parts are performing in the real world, and stopping those failures before they happen?
Exactly. And I think, like you mentioned, predictive maintenance of, the machinery and all of that, I think that has been a great use case for the companies and customers we have in the manufacturing industry. And also, would you like to talk about a couple of use cases or customers?
Yeah, absolutely. So one of the great use cases is actually QP Mayonnaise, who manufacture baby food, and on their conveyor belts, essentially they have human beings, looking at the quality of these potatoes, and they looked at other, various devices that could do this, and those things would cost hundreds of thousands of dollars. But by using things like TensorFlow and imagery, they're actually able to use the imagery in order to predict which potatoes are bad. And once they're doing that inference, they just have a small sound, and they no longer have people there watching those belts full time. It's just whenever they hear the sound, as rare as those instances are where they have a defect, that person can then go over there, find it on the belt, and remove it, and then they can go back to doing other activities.
So I think it's interesting to note that how we can, how they have been using the video intelligence API for that regard, and kind of just getting that conveyor belt, video snippets into there, and how they've been analyzing it to kind of red flag any, any miscalculated or faulty piece that they get of potato. So very interesting use cases there.
Yeah, and really getting rid of the mundane as well, right?
Exactly.
So they're actually able to take those workers and reassign them to more valuable activities.
Absolutely. So I think on the same track, the next session that we're going to have is our fireside chat with General Motors and Marriott. So I think that should be very interesting because they are two of our customers, and it should be fun to get in touch with them and understand what are the use cases and how Google Cloud has helped them.
Right, and they're going to be talking about job discovery, and there are a couple of other customers joining them as well to talk about how they're using things like job discovery to essentially match applicants to the jobs which they're qualified for. So, I know if I were to go onto a website and search for server jobs, I think to us being in IT, that would mean something completely different to somebody at Marriott who is looking for a job to be a server. Right, so it's the ability to take those things in context and use machine learning to figure out exactly what the user wants and match them with the appropriate job.
And that's interesting because that's one of our pre-trained APIs that we were speaking about earlier. So you don't really need to go ahead and train your own machine learning models. You have a pre-trained API from Google, which is the Cloud Jobs API, which enables customers like GM to kind of go ahead and use that on their job sites. So it should be very interesting. Stay tuned for that. In the meanwhile, I think we have the AI track, which is just wrapped up. So again, welcoming our audiences from the AI track, which they just attended, about how they can accelerate machine learning in the cloud using GPUs and cloud TPUs and much more. And
yeah,
yes,
so I think especially for things like cloud TPUs, as you're talking about sort of accelerating machine learning, the more you can accelerate, the more you can experiment and try, then the faster you can innovate as an organization. And that's why we provide things like that. And that track will also be joining the fireside chat with General Motors and Marriott, talking about job discovery. So thank you very much, and enjoy your sessions.
Yes, and please stay tuned, and you can continue to feed in your questions through the Q button that you see on the right-hand side.
Welcome back to Cloud on Air, the journey from big data to AI. My name is Scott Ellis. I'm a product manager in the Google Cloud Privacy Infrastructure, and I'm going to be talking about the principles of data security and privacy in Google Cloud. Google experts are standing by to answer your questions, so please fill them out in the Q&A section. Now let's get started. Today what we're going to cover is we're going to talk about sensitive data and security, but first we'll give a quick intro about sensitive data, cover some basic security principles, and then we're going to give you 5 steps that you can take to help you protect your data. Then we'll show you some tools and some demos, tools that can help you do this, and then we'll give a quick recap. So to get started, let's just give a kind of quick intro about security and privacy. As organizations move to the cloud, security and privacy of their sensitive data is one of their top priorities. This is crucial for just about any industry, any business, and especially as data is moving into the cloud. So let's first go over some examples of sensitive data. Some examples include personal identifiable information, or PII, financial data, health data, And these can come in a lot of different formats. So it could be documents, it could be images, these could be in databases or in your production systems. And it could come from a lot of sources. For example, it may be data collected from or about your users. It could be data collected from or about your employees. Or it could be data that is shared or comes from partners. Some examples of this, just to give some examples of PII, might be names, addresses, phone numbers, social security numbers. In financial or healthcare data, you may also have payment information like credit card numbers or sensitive health information about individuals. And so what are some of the common goals in handling sensitive data? Well, you kind of break it down into two. First is you want to use data properly. And this might map to things like the concept of least privilege or need to know. And so you really want to do the right thing. But what's also important is you want to be accountable. And what this means is you really want to be able to demonstrate that you are using the data properly and demonstrating that you're doing the right thing. And those two things are kind of the ultimate goals here. Do the right thing, be accountable, and be able to demonstrate that you're accountable. But there's some challenges there. First, just keeping track of your data. Data can come from corporate environments, including things like email or document sharing. Data can come from mobile or web apps. Data can come from analytics systems or maybe be shared for analytics or other business operations with partners. And the challenge is maintaining strong governance as the business operations grow and as data itself grows from all these different sources. Another challenge is just restricting access. Again, your goal is to use it properly, ensure things like least privilege and need to know. So you really need to ensure the right level of access control. But you want to do that with a minimum hindrance on business and minimum hindrance on service to your users. You don't really want it to impact your business operations. And so here are 5 steps that you can take to help protect your data. And these kind of break down into 2 categories, administrative and technical. So first, it's establishing the right policies and procedures. The second is educating, making sure every stakeholder knows about your procedures and policies. And then on the technical side, it's really classifying your data, restricting that access to that data, and then employing some techniques like masking, de-identification, or transforming the data to further reduce the risk. And we're going to now go into a little bit more detail about all of these. So first step we talked about was having the right policies and procedures. So first, you want to have policies that cover things like the following. You want to make sure you establish what you can and can't do with data. So consider things like industry regulations, local, state, regional, national laws, partner contracts. You may have signed an agreement with the partner. You want to make sure that you are following those terms. And a really important one is user expectations. What are your users expecting you to do with this data? Because you want to provide a valuable service, but you also don't want to surprise them or not meet their expectations on how you're handling data. You also want to establish procedures and approvals for escalations, incident reporting, and incident response. You want to make sure you have a very good process for handling all of that. And finally, review everything periodically. You want to make sure that as these things change, that you update your policies and that you just keep aware that they are keeping up with the data you're collecting and the kind of things that you're doing. It's part of your business operations. The second step is really to educate. You want to make sure your employees know your policies. You want to make sure your partners and subcontractors know your policies. And really just make sure everyone involved with your data understands your policies and procedures. And education is not a one-time process. Key thing is you want to repeat it periodically. Again, as you're changing your policies, you want to make sure people know about that, but also just to remind them and really make it a part of your company culture. And now we're getting to some of the technical steps. So first, you want to make sure you can find, discover, and classify your data. Know where your data is, where sensitive data is collected, where it's stored, where it's processed, where it's used for analytics, where you're sharing it with partners, and also just how long you're retaining it for, how long you're keeping it, and when you are deleting it. And you also want to address areas where sensitive data might be inadvertently collected. So again, these are areas where you don't expect it to be, but it could show up. And we'll give a couple examples of that later on in the demos. Next, once you know where your sensitive data is, you want to really know how to restrict access to your data. And here's just a few examples of the tools and techniques that you can use to restrict access. First one is really access control, making sure that the right users can't gain access or can't see the data that that they don't need to see. The second is even for users who have access, you want to make sure you have you generate logs and have very good audit logging and auditing procedures to make sure that these users are accessing the data for the right purposes and the right use. Other things to consider as well are encrypting your data. Again, making sure that it is safe, encrypted at rest and in transit, so that it can't be intercepted or used kind of used in a way that you're not expecting. Another form of protection is to turn on things like two-factor auth or multi-factor auth. And really this is to help reduce the risk of phishing and other account vulnerabilities to make sure that the person who is accessing the data is actually the person that you expect. And step 5 is really when you look at your data, are there further ways you can reduce the risk by using techniques like masking, de-identification, or other forms of transforming the data? So consider these to further reduce the risk. Maybe you want to scan and redact data to prevent inadvertent collection in those areas where you're not expecting sensitive data, but it could be collected. You can scan and redact it on collection. Also, maybe look at tokenizing PII or identifiers instead of sending the raw data. So this might be for analytical purposes, or when you're sharing with partners, you can take some of these approaches to reduce that risk. Some other forms or other techniques you can use, again, dynamically masking the data, partially redacting the data, using techniques like format preserving encryption and bucketing to further reduce the sensitivity of the data. And we show a few examples here on this slide, but I'm also going to show a few demos later on some of these specific techniques. And let's get into the demos now. So first, let me cover just kind of some of the broad techniques for securing your data. There's also some very valuable links here for some more detail. But first, did you know that Google Cloud Platform encrypts your data at rest and by default, without any user interaction? This is turned on for you. But we also give you more control over this through things like our key management system, or KMS. You can also manage access control with our cloud identity and access management, and even further expand this control by project, folder, and organization using the Cloud Resource Manager. So these are all very valuable tools that can help you secure your data. And next, we're going to focus on some tools to help you really focus in on the sensitive data and understanding that. And the first step in handling sensitive data begins, again, with knowing where your sensitive data exists. So the following tools will help you do that. For our products, many of our tools and products fall under the term data loss prevention. And really, what this means is helping to identify sensitive data and helping to reduce the risk of it being inadvertently exposed or leaking into areas where it should not be. So for us, this is a suite of tools, and we're going to cover a few of those right now. The first one is our Cloud DLP API. This one provides 3 core capabilities. The first is to help you classify sensitive data. And this, again, is data like personally identifiable information, or PII. It can also help you mask the data and do some more advanced techniques like format preserving encryption. It can also do some re-identification risk analysis. And these are some more advanced analysis tools like k-anonymity, L-diversity, and a few others that we'll show that can help you look at structured data and really try to understand some additional sensitivities to it. And overall, we see this API as something that you can apply to raw data. You can produce things like redacted data, and again, help you do analytics, sharing of data, and maybe even app development with reduced risk and in a safer environment. So let's go over a simple example. So imagine this text that you see here on the left is collected through one of your applications. Maybe this is a live chat, maybe it's a feedback or email that comes in. But imagine you collect this information. So when we talk about inspection or classification of sensitive data, what we're talking about is going through this text and identifying the sensitive bits. So in this example, we've shown things like name, social security number, phone number, and email address that were found in the text being identified. And these are what are highlighted in orange here. So again, inspecting the data, just knowing what's there. Now, in some cases, you need this information, and you would collect it, put access control, restrict access to it properly. In other cases, you may not need this information. So in the next example, we'll show how this could also be masked or redacted. So in this example, we've gone in and replaced the name, the social security number, and the phone number, and the email address with different forms of masking or redaction. So for names, we simply replaced it with a a word indicating that we found a name there. That's also what we did for email address. For the social security number, we replaced it with an encrypted hash. And for a phone number, what we did is we did what's called a partial mask, where we just masked the last 7 digits of the phone number, but left the first 3. So again, we're showing sort of a variety of techniques here, just to kind of illustrate the power of the different tools and techniques that you can have at your disposal. So where would this fit into your workflow? So really, you can plug this, because it's an API, you can plug this in several places into a workflow. So I'm going to go over a sample workflow here. So imagine you had a web or mobile application that was powered by something like App Engine. And behind the scenes, you also took data from this, processed it, and piped it into BigQuery for doing analytics. So you could use something like the DLP API and plug it in at the front end to help you, classify and reduce the risk of collecting this information in-app in real time. Maybe you did not expect to collect certain things, so you could scan it and classify it, redact it before you saved it. So again, plugging it in at the front end. You could also plug it in behind the scenes as you're taking this data and moving it in for, let's say, analytical purposes in sort of a batch. Like maybe you take all the data you collected every day, every week, every month, and you process that and move that into BigQuery. So you could plug this in here to, again, go classify and redact this information before you did analytics. You could also use the DLP API kind of after the fact. Let's say your data is already stored, it's already at rest, and you really just want to know where it is, and maybe use that information to set security policies like identity and access management policies. So in this case, we're showing how you can scan the data, let's say sitting in BigQuery, and use the classification findings to then go and inform who has access to it or to restrict access using identity and access management. So let's actually show this, this in a real app. So here is a screenshot of an app here that kind of represents a common customer chat app. So imagine, again, you have a live chat with your customers, and what you want to do is you have your customer support agent and your customer interacting back and forth. And this shows an example where a customer support agent asked the customer for some information to validate their account. In this case, they asked for the last 4 digits of the social, which is what their business practices approve to validate the account. But unfortunately, the customer gave a lot more information. In this case, they gave their phone number, they gave their full social security number, they gave their email address, and then they even scanned a picture and uploaded it in the chat of their social security card. Again, this is a little bit of a good example of oversharing. And what we're trying to show here is that the customer simply provided this information, even though it really wasn't something that the customer support rep needed or that you wanted to collect. So this is how a chat app might run today, where this information just comes in, the support agent sees it, you might save this, you might archive this, and this might go into your analytics systems. So now we're going to show what this might look like after, if you had integrated the DLP API, which you could have done. We're showing the original chat on the left and the modified chat on the right, where we've actually masked the data on collection. So in this case, it's highlighted here in red. We've shown how all of the identifiers that were deemed sensitive, the phone number, the social security number, the email address, and that information in that image are redacted. So in this case, we've been able to dynamically redact it. And you'll see with the social security number, even though the customer supplied the full social, we're masking it to only show the last 4 digits, which is what the customer support rep needed. In the case of email address and that picture that they scanned in, we just redacted it all out because that was not needed. So again, this is showing an example of using this API in a third-party app or a custom app that you build yourself. And so now let me actually show a live example of an API call. So what we're going to do is I'm going to jump into our API Explorer. And there's actually the link that's on there you can actually run. But I'm going to go ahead and show you this kind of live example. This is an example of an actual API call. What we have done here is we've taken that example that we first started with, where we had a block of text that was sent in. We've specified through the API different things that we want to look for and different things that we want to do to try to mask or redact this information. And I'm going to go ahead and click Go. And what we'll see here is that API call request goes in, and immediately I get back a redacted version of it. So what we're seeing here is just how easy it is to use this API to send in text and get back a redacted version. Very easy. You can run it yourself. Let me get back here and show you that link. And so yeah, so you can go to that link and try it yourself, modify it, test it out, and see how easy it is to use this API. So now let's kind of take a different approach. So we've kind of shown you how the API works and how you can build it into your custom applications. But what if you want to use it to know where you have sensitive data that's already in cloud storage? So again, imagine you have this question again, where's my sensitive data? Where do I have it? This may be data that was collected through applications and is already stored, or it may be data, again, that you just uploaded and have in what we call Google Cloud Storage, which has file folders and buckets, buckets that hold folders and files, or it may be data that is sitting in something like BigQuery. And really what you want out of this is you want to be able to scan those things and get some sort of summary report or findings on what files had sensitive data, maybe a count of that data, and maybe the types that you found in there. So let's just give some examples here. So on the left side, what we're showing is, imagine you had a cloud storage bucket, and what you really wanted to do is get results that say, what did you find, what confidence was it that you found it, and what location was it in? And on the right side, what I'm showing is an actual API call to do that. So the difference here from what we showed before we actually sent the data into the API call, and here what we're showing is that you can actually just point it to a cloud storage bucket to scan. So in this case, we've indicated the bucket to scan, where we want results sent, and then defined what we want to look for. So again, in this case, we've only turned on 4 of our classifiers, but this gives you an idea of how easy it is just to specify a bucket and get results. BigQuery is the same thing. You'll notice it's a very similar request. The only difference here is we specified a project, data set, and table instead of a cloud storage bucket, but the rest of it's generally the same. And then you'll get data back. And again, instead of files and folders, you will get back things like maybe rows, column names, things like that. And let's look at the BigQuery example a little further and see what we can actually do with it. So I'm going to take you through an example here. Imagine you had a BigQuery table that really didn't have any field names. So for example, maybe it was just called things like field 1, 2, 3, 4, 5, 6, 7, 8. You really didn't know what was in there. What you wanted to know is, can we guess or can we analyze and figure out what is in these fields? So we took this table, we ran a query very similar to the one I just showed. In this case, we've specified the input table. And in this case, we've actually specified that we want to write findings directly back to a new table in BigQuery. In the previous example, we showed the findings going straight to cloud storage as CSV files. Here, we're going to write them directly to BigQuery. And the reason we did that is we now want to go back into BigQuery, look at the findings, and run SQL queries against them. So here's an example of that. This is a SQL query that we ran on that table. And if you remember, again, it just had fields 1 through 8 as the header names. And what we did is we ran this query. And what's highlighted in red here is we've shown that by looking at the results, we can predict what is in these fields. We can basically classify these fields for you. So in this case, we've shown that field 1 is pretty high confidence. We found 88% of the fields were IP addresses. And in field 8, 92% of the fields had phone numbers. And you'll notice a couple of these fields had multiple findings. I'll point out one that's really interesting. Field 4, the majority of these were email addresses, but there was also a very high amount of findings for name. And the reason for that, again, is email addresses often have names in them. So again, we're showing all the details here. 15% of these emails also matched for a person's name. This is the kind of power you get. And by putting this information straight into BigQuery, you can run a lot of very powerful queries using the power of SQL. And so again, here's another example. So again, this is just looking at that same table, running a different query to demonstrate that you really could run any SQL analysis against these findings. In this case, I've run a different query that simply counts the types of that run and says, what were the most common things you found, count them up by type, and then kind of sort by that type. So again, anything you can imagine in SQL, you'd be able to run with these findings here. And next, we're going to show examples and demos of transforming data. This includes masking data, tokenization, hashing, and a few other techniques. So first, let's just give a few examples of what this is. So I'll start with an input. Let's imagine we had a string of text that included a phone number. And we want to mask this phone number because the phone number could be identifying. So one technique is to use partial masking. In this case, we would mask just part of the phone number. And we've chosen in this example to mask the last 7 digits of the phone number, but leave the first 3, which is an area code. And that area code may be valuable for analytics, but you don't want to keep the last 7, as that might actually reveal the identity of the person. So again, partial masking is one technique to keep some value in the data, but mask some of the more sensitive bits. The next 2 examples we're going to show are examples of tokenization. This is sometimes referred to as pseudonymization, or using a token or a surrogate to replace the original identifier. So in this case, the identifier is the phone number, and we are replacing it with a token that kind of acts on behalf of the phone number. So in this example, we've shown the same sentence, but the phone number has been completely replaced with what we call a secure hash. So this is a random or a string of numbers and letters that looks pretty random and is generated based on a key that's provided. In the last example, we're showing a version of this token using what we call format preserving encryption. In this case, we've picked a token that has a similar format to the original input. And this can be, again, it provides the same basic use, but it looks and feels a little bit more like the original identifier. It just isn't the actual original identifier value. So in this case, again, it looks like a phone number, but it isn't the actual phone number that we started with. And in both of these cases, these are done with cryptography, and you would provide a key. And depending on what key you provide, you could get the same token out in subsequent runs or in multiple data sets. So again, imagine if you wanted to correlate this data or look at 2 data sources and see that this is the same phone number. Depending on how you manage the keys, you could generate the same token and see that the same phone number was used without actually revealing the underlying original phone number. Another technique is bucketing or generalization. And we're going to show one example of this here using something that's sometimes referred to as a quasi-identifier. This is a type of data that isn't as obvious or as a direct identifier, something maybe like a phone number or email address, but still could be pretty identifying. In this example, we're showing job titles like senior engineer, junior engineer, distinguished engineer, and we are bucketing them into something a little bit less distinguishing, which in this case would just be engineer. This technique can be very valuable if you have something that's very specific and you want to take it to something a little less specific, but still preserve value. Again, on the right side table, we still know that they're an engineer versus an operations manager. We've just lost a little bit of the data and made that trade-off to reduce the risk a little bit and preserve a little bit more of the privacy of the data. And this brings me to my last example. We're going to talk about some risk stats like canonymity and L diversity. And it's very much related to the bucketing example we gave. So imagine now you had that job title and it was next to some sensitive metric. In this case, we've just shown an integer, but imagine it's something sensitive like salary or something else. And for job title, it's seemingly like this wouldn't be that identifying, but in the example I've shown, we have 5 values, 4 of which are software engineer, and 1 of which is CEO of Google. And it's pretty obvious that if you saw CEO of Google next to something, it wouldn't be that hard to guess who that was. And so that's something that we would consider potentially identifying. Using tools like canonymity and L diversity, you can analyze structured data like this and try to find those high-risk outliers. So in this example, something like software engineer would have a K of 4, and CEO of Google would have a K of 1, because it's the only value in that data set that would be CEO of Google. L diversity starts to look at the metrics and other things that it's tied to know how diverse those metrics are. So in this case, software engineer had the K of 4 and an L of 2 because there are 2 different values that map to software engineer, in this case 5 and 8. And this is a technique that can be used for analyzing your data as well as informing some of the bucketing and generalization that we showed earlier. And that's the last example. And just to recap what we've talked about here, the key things here are knowing what data you're handling. You want to protect your data. You want to follow things like least privilege and need to know. First off is know the data you're handling. Use tools like the DLP API to help discover and classify your data. And then make sure you control exposure of your data. Set access control and identity and access management policies. And also use tools like the DLP API to minimize the inadvertent collection of this data in the first place. And further reduce the risk of your data by using tools to mask, redact, and transform your data. And this can help, again, reduce the re-identification risk of your sensitive data. And that's all I have for today. But stay tuned. Thank you for watching, and stay tuned for the next session.
Coming in very, very quickly. And then finally, the variety of data, which means you've got lots of different data sources, and you want to combine that data together because it's more valuable together than it is separately. So our big data track has also just joined us, and we were just talking about what big data is. And we were talking specifically around volume, variety, and the velocity of the data that's coming in. And we have different things, different tools in order to address each of those, right? So in terms of volume of data, we talked a lot about BigQuery in these sessions and how you can actually use that to simply upload and query the data and make sense of that and then do interesting things with that in terms of your AI lifecycle. For the velocity of data, we talked about things like data prep to help you make sense of that. And underlying data prep for ETL, you have things like data flow to help you take that real-time data pipeline and process that very quickly so you can act on that in the moment through, for instance, an AI inference model. And then in terms of the variety of data, so also being able to create multiple input pipelines, again with data flow, and multiple outputs as well, so you can combine that data in different ways. And then also in terms of that data warehousing aspect, being able to combine all the data inside of a data warehouse like BigQuery, so I can just upload it, not have to analyze it, not have to scale it. I just run a query, right? I just ask it a question, and it gives me the answer back, and it does that in seconds.
I think what's interesting is also to note that BigQuery doesn't really charge you on the size of data that you're placing in there. It only charges you for the amount of data that is being processed. So that's really interesting, because you might have say tons of rows of data, but only the data that is being processed as per your efficient query that you're writing, SQL query. That's how you're being charged for, which is really I would say it's a nice pricing model.
Yeah, definitely, right? If you're not querying it, you're not paying for anything.
Absolutely.
So one of the other questions was, as an experienced developer but new to machine learning and AI, where do you start? So congratulations for coming to these sessions. That was definitely a good start.
Absolutely.
And we talked a lot about the other training and stuff that you can do. But I think as if you're a developer, it kind of starts the same place that everybody else does. And if I think about sort of Cassie's session earlier, it really starts with the answer that you want. So what kind of answer are you looking for? What kind of question are you asking? Is there a pre-built model that will give me those answers? If so, you can use one of those pre-built models, right? And at Google, we have quite a few different models that you can use in order to address those concerns. If there are answers that you need where we don't have models, there are lots of models available. Now, you will need some TensorFlow knowledge. Luckily, you can go to tensorflow.org and find out a lot about TensorFlow. And there are also there's the GitHub repository where you can download TensorFlow, but also repositories of models that you can use. And you can actually use those and actually just change those, modify those in order to meet your needs as well. And then finally, you can use tensorflow.org to learn about TensorFlow and start to create some of your own models.
That was interesting, Jay. So I think just kind of wrapping up our session, it was, it's been a very long, 4.5 hours of event that we've had, and amazing job to all the folks who've attended the sessions, the ones who've delivered the sessions, and all of that. Thank you so much, Jay, for being my co-host.
Thank you, Shaista.
Today, and I thank all of you for joining in and tuning in. And for those of you who kind of missed out the sessions, please feel free to join us in the EMEA slot. And that's it. And thank you, and see you soon in another Cloud on Air.
Thank you.
you.